How do you write unit tests? These are automated tests that verify the functionality of a small component in your system called a unit, where a unit could be a class or a particular method on a class. In this video, I'm going to show you how to write unit tests for a domain service and what are all the problems that you will need to solve in order to write high-quality unit tests. The follower service here will be the unit that I will be testing, and I'm going to focus on the one public method that this service exposes, which is the method to start following a particular user. You will notice there are a few branches in this method that are worthwhile to test because they represent validations, and I'm also going to show you how to verify external services such as the follower repository that are injected into our domain service. So let's start off by creating a new folder in the unit tests project, which I will call followers. And then I'm going to add a new class inside, which will hold the test cases for my follower service. So I'm going to call this follower service tests. The first test case that I'm going to write inside of this test class will check if we are trying to follow the same user. So I'm going to use a fact to represent my unit test. Now, because this method is asynchronous, I'm going to make my unit test return a task, and I'm going to start the name of my test with the method that I'm testing. So this will be the start following async method. Then I'll say should and explain what I'm expecting to get back. So I expect this method to return an error when we are trying to follow the same user. So I'll say when following same user. And I'm going to add the arrange, act, and assert comments. And now I can start building out the body of my unit test. So first of all, I'm going to need my follower service, which I will be testing. So let's create a new follower service instance. I'm going to pass in null for the follower repository for the time being, because I don't need a follower repository instance for the first few tests that I'm going to write, but we are going to circle back to this a bit later when we talk about mocking. The next thing I need is the argument that I'm going to pass to my method, which is a user instance, and to create a user, I'll need a name and an email. So I'm going to create an email by calling the static create method, and I'm going to pass it some email address. Then I'm going to create a name instance by passing in some value for the name. And finally, I can create a user by calling user create, passing in an email and a name, and a value for the has public profile flag. Let's pass in the value of false for the time being, and we'll see how this affects our test cases. So now I'm ready to execute my test, and I'm going to store the result returned by this method in a variable, and I can call the follower service start following async method and pass it the user instance. Now, because I want to test the case when I'm trying to follow the same user, I'm going to pass in the user instance twice. Then I'm going to pass UTC now for the current time, and I'm going to pass default for the cancellation token. And now I'm ready to write my test assertion, which is going to check that the error on the result object should be, and I already have my domain errors documented inside of the follower errors class, and the one that I'm looking for is the same user error. Now, if I navigate to this field, you'll see that this is an error instance with a unique error code, in this case the follower's same user error, and this is the specific error returned in the start following async method when I'm trying to follow the same user as the current user of the system. So if I go back to my test and try to run this test, let's see what we get back. So here are our follower service tests, and you'll see that our unit test is passing. Before I write the next unit test, I'm going to clean up my test setup a little so that we simplify it for the future tests. And I'm going to extract the follower service, email, and name into fields on my test class. So the follower service will be a private read-only field. Let's call it the follower service. I'll give it a name. And I'm just going to instantiate a new follower service without a repository instance. And I'm going to do the same for my two value objects. So I'm going to create a private static read-only field for my email instance, and I'm going to assign it the value, and I'm also going to do the same for the name instance. So this will be a private static read-only field called name, and it will have this value. One more thing I can do is create a field for the current time. So this will be a date time object, and it will have the value of the current time. Because time doesn't play a role in our tests, I'm just going to capture the time in a static variable at the start of our test. So what this will allow me to do is to significantly simplify my unit test, and I'm going to obtain my email and name instances through my static fields. The follower service will also be a static field, and I can simplify my arguments to also use the date time UTC now field that is present on my test class. I'm going to run my test again to see if it's still passing, and if our refactor was successful, it should be green, and you can see that this is the case. And now let's go ahead and write a few more unit tests in our test class. So the next test case I want to write will check this condition if we are trying to follow a user that doesn't have a public profile. Here's what a test like this would look like. I'll create a new test with the fact attribute. It's going to be asynchronous, and I'll call it start following async should return an error when following non-public profile. So this is a relatively descriptive name for a test. I'm going to copy the steps from our previous test, and let's adjust them so that we can satisfy our new test case. So I want to check if the followed user doesn't have a public profile. So let me create another user instance. I'll pass in the same email and the name because it doesn't play a role in differentiating between these two users because they are identified by their identifier, which will be different for two user object instances. Now it's important that I pass in the false flag for the has public profile in order to trigger the validation in the follower service. I also need to pass in the followed user as the second argument, and I'm expecting the error that is returned by this test to be non-public profile. So let's execute our two test cases, and you will see that they are both passing and verifying the expected behavior of the follower service. The next test case I want to write is the one checking if we are already following the followed user. This requires us to call a method on the follower repository, which is going to head over to the database and return this information back for us. And if it returns true, we're going to return another error instance, in this case, the already following error. However, because we are writing a unit test, we don't want to introduce external dependencies, in this case, the database. So how am I going to solve this? Well, I'll need to introduce a mocking library, and there are a few of them that you can choose from. The popular one is mock, although it's been a part of a bit of a controversy in the previous weeks, so I'm going to show you a different one, which I actually really like, and it's called NSubstitute. And you'll see that this library is very easy to use because it has a nice Fluent interface for creating your mocks. So what I'm going to do is head back to our setup of our fields, and I'm going to get rid of this initialization of the follower service, and I'm going to add another field for the iFollower repository. Now this is just an interface. I don't have any implementation for this interface in my project whatsoever, but what I'm going to do is provide a mock for this interface using the NSubstitute library. So the follower repository is going to get a value using the substitute class, and I call the for method to specify my iFollower repository as the substitute that I want to get back. Then I'm going to create the follower service by calling the constructor, and I'm going to provide the follower repository instance. And I'm actually going to rename this field into follower repository mock to be explicit that this is actually a mock interface. And a quick explanation for what mocking is: it's a way for us to provide a dummy implementation of a particular service, in this case the iFollower repository interface, and the value of this is that we can configure the behavior on the mocked instance. I'm going to show you how to do this right now. So let's create another test in our test class. I'll use the fact attribute, make this method asynchronous, and give it a name. So start following async should return an error when I'm already following the followed user. So this is the detailed name for our test, and I'm going to copy the arrange, act, and assert steps, and let's see how we're going to set up this test to utilize mocking. So first of all, the followed user needs to have a public profile so that we don't get back a non-public profile error. then I need to make sure, obviously, that these aren't the same users. This is already correct. However, I also need to control what happens in this step here when I'm calling the external service. So because I'm using a mock for the follower repository, I need to configure this mock, and I can do this by accessing the follower repository mock instance. Then I can access the method that I want to call. In this case, the isAlreadyFollowing async method. Let's give it the arguments that it is expecting, and these are the user ID, the followed user ID, and the default value for the cancellation token. And then I'm going to call a method which is exposed by the NSubstitute library, and it's called returns, and I can configure the value returned by the mocked instance of my interface. So in this case, I want this method to return true, which will make the if statement evaluate to true and return back an error. So if I update my assertion to check for the already following error and I execute this test, I'm expecting my new test to pass, and you can see that this is the case. So this is how we can use mocking with the NSubstitute library to set up our external services and configure the behavior of these services. So now that we verified all the failure conditions in our start following async method, we can finally test the happy path when we end up creating a new follower and inserting the follower to the repository. So I'm going to create a test that's going to verify this behavior. So let's start writing our new test case. So I'm going to say start following async should return success. And I'll say that the condition for this is when a follower is created. I'm going to reuse the steps that I had in the previous test case. And let's see what we need to update to end up creating a new follower. So first of all, we need to make sure that these are not the same users, that the followed user has a public profile, that the mocked version of the follower repository returns false when we call the isAlreadyFollowing async method, and we need to verify that the result instance that we get back is a success result. So I'll say result is success should be true. And this is enough to verify the happy path in my domain service. So let's execute our test, and you'll see that my test is passing. Of course, these tests are no good if they don't verify the behavior that you are testing. So an easy way to verify this is to just update something in the test setup. For example, let's update the return of our mocked repository to true and rerun our test, and you'll see that our new test is failing. The same would happen if I were to update the public profile of the followed user to be false and rerun the test. You'll see that the test is failing. So let's fix the test. And I want to show you how to write one more type of test. Let's say that we want to verify that we actually create a follower in this method. We aren't returning anything from our domain service, so updating the return type of the service would be one approach. However, what I want to do is to verify that when I call the insert method on the repository, the follower instance that is passed as the argument contains the correct values in the properties. So I'm going to check if it matches the user ID and the followed user ID. So here's how I would write this test. I'm going to create another test case. I'll start with the same naming convention. So start following async should, and then I need to describe what should happen. So let's say it should call insert on the repository when the follower is created. So I'll just say when follower created. Of course, I need to make this return a task to be a valid test case, and I'm going to use the setup from my previous test case with some slight adjustments. I still want my start following method to succeed, but I don't want to verify this in my test because I try to do just one assertion per unit test. So I'm going to completely get rid of the result returned by this method, and we're going to do our assertion using the NSubstitute library. What I can do is access my follower repository mock and then call the received method, which is exposed by NSubstitute, which allows me to check if the mock has received any number of calls to a particular method. So let's say that I want to check if we received one call to the insert method, and then how do I verify that the follower that was specified as the argument contains the correct values? What I can do is access the argument class, and I can say is, and then specify the follower as the generic argument, and this will allow me to specify a predicate to check the state of the follower instance. So I'll check that the follower user ID is equal to the user ID of the user that we are passing into the start following async method. And I'm also going to verify that the follower's followed user ID matches the actual followed instance's user ID. So this is what a test verifying our mocked instance would look like. We're checking if the insert method was called with an argument matching this predicate. And if I run all of my tests again for the follower service, you'll see that they are all passing. So now we are checking all the possible paths in the follower service start following async method. We are checking all the validation failures. We are checking that we are calling the insert method on the repository and also the return value from this method. We aren't checking anything pertaining to the follower entity. This behavior should be tested in isolation separately from the follower service because it represents a distinct component or unit in the domain. And one more thing I want to show you is the concept of code coverage. So because I have ReSharper, I can use ReSharper's test coverage tool to cover all the tests in my solution. And when I do that, I'm going to get back a coverage report. And let's take a look at our follower service, which is in the followers namespace. And you'll see that we are getting 100% code coverage. So the unit test that we just wrote for this service covered all of the lines in this method. And you'll see that ReSharper is giving me some code highlighting here saying that these lines are indeed covered by my unit tests. So if I take a look at another example, for example, the follower entity here, you'll see that I have some code that isn't covered. For example, I'm not calling the created on property anywhere in my test. So if I wanted to fix this, I could go to this unit test here and update the assertion that I'm writing here. And I can verify that the created on date and time is equal to the one that we pass in to the start following async method. So if I run my unit tests, you'll see that they are all still passing. And if I rerun the code coverage tool to cover all the tests in my solution, you'll see that it updated the created on property, which now has a 100% code coverage because we are testing both the getter and the setter of this property. This isn't something that I will pay attention to most of the time. I'll just focus on writing quality unit tests like I'm doing in this test class here. And in practice, you will see that if you follow these principles, code coverage will already be pretty high. If you enjoyed this, then take a look at this video next, where I explain how to write parameterized tests with XUnit to write better unit tests in C#. Make sure to smash the subscribe button on your way out so that you don't miss any of my future videos. And until next time, stay awesome.